Hello, today we are going to study a chapter, light. Now, I'm sure you've all studied chapter light in your 7th standard. They told us some laws of reflection, some other things. Now, one of the very important things that we'll be carrying on is that law of reflection. Now, I'm sure many of you would have wondered why is I equal to R, and you know what is this, okay? You just mug it up, you write that angle of incidence equals angle of reflection, and you write the angle of the incident ray and the normal and the reflected ray at the point of incidence. They all lie on the same plane. Okay, you get the marks. But why is it true? Can we prove it? I think we can prove it. So you might read your Fermat's principle of time, or light is in a hurry. Now what do I mean when I say light is in a hurry? When I say light is in a hurry, I mean that given any 2 points, light will always take the quickest path connecting them. Now mind you, when I say the quickest path, I do not mean the shortest path. Because the shortest path may not always be the quickest path. Let's suppose you live in a city and you want to go from one place to the other place. Now the shortest path connecting them would be the road, would be the straight road connecting them. But suppose there is a lot of traffic, so your father might take the other route which is longer, but then you would reach quicker. So light would also take that route. Alright, so this is a basic setup. Now what is this? We have a crow here, and this is a mouse, and this is a nest. So what does the crow want to do? It wants to take the mouse and it wants to take it to its nest. Alright, so basically here we are trying to prove that angle of incidence equals to the angle of reflection. Now you might not wonder, oh, we have a crow, we have a mouse, and we are trying to prove about light. But you're going to see just soon that how we are going to prove. Now we're going to make some basic assumptions. The crow always travels in straight lines and it wants to take the quickest path possible. Now the astute ones amongst you will begin to understand where I'm going with this. Crow is the representation of our light. So where should the crow catch the mouse? Should it catch it here? Should it catch it here? Or should it catch it, in between? Let's say it catches anywhere. Now, firstly, we'll have to extend this line here. Now, let's say these two lines are equal. Now, what's the quickest path between these two points? The quickest path will be the shortest path, that will be the straight line connecting them. So, alright. Now, let's draw another line connecting these 2 points. Alright, so this angle equals 90 degrees, that we know, because it's a pole and it's 90 degrees. And these 2 lines are equal and this line is common. Thus, these 2 triangles are congruent. So these 2 lines are equal. So this is the shortest path connecting these 2 points, then this must be the shortest path connecting these 2 points. Of course, the shortest path connecting these 2 points would be a straight line, but we are talking about a pi, we are talking about the ray of light that actually goes to the mirror and reflects. So does light want the angle of incidence equal to the angle of reflection? No, light really doesn't care. So we can say that this is the shortest path. Now since these 2 lines are equal, since these 2 poles, or in our case, so we will find that this line equals this line. That means light will come exactly in the middle, or the crow will catch the mouse exactly in the middle. Now since we have that these 2 lines are equal, and this line was already equal as these 2 poles are equal, we will have that these 2 triangles are congruent. Now if they are congruent, this angle equals to x, and this angle can also be equal to x. Now let's draw the normal. I'm sure you know what the normal is. So this is equal to 90 degrees, and this will also be equal to 90 degrees. In other words, this angle, mind you, which in a way can be considered as the angle of reflection, and this can be considered as the angle of incidence. So this will be 90 minus x, which will be 90 minus x, and this will also be 90 minus x. So the crow comes here, catches the mouse and takes off. In other words, we've just proved the law of reflection, which is angle of incidence equals to the angle of reflection. Now this might seem pretty cool, right? So if anyone asks you about this law, you need not just say it's law 1, you can say, oh, I can prove it to you. So moving on. might have noticed we started with a very basic, with a very simple principle, which is light is in a hurry. And we have come to the point where we have easily found out the angle of reflection, angle of incidence equals to the angle of reflection. Alright, now we are going to do a little brief talk about the plane mirrors. Now you all know, I'm pretty sure you all know that it's a virtual image that we get in plane mirrors. Alright, so let's say this is a ray of light here. Okay, it goes here, and we know that it will follow the law of reflection, and it will go off from here, and another ray here, and it will go off here, and then this. So when we see these two rays of light, they're never going to meet, are they? No, they're never going to meet. But our eyes sees these two rays of light, and it thinks, oh, two rays of light, they must have come from a point. And our brain runs a back simulation. And this concludes that this must be the image. So this image really does not exist. It's just a backward simulation that our brain runs. Alright, so I am sure that you would have understood by now how the virtual image is formed. Now we're going to talk about spoons. You all must have seen spoons, you would have seen your face in that spoon. I'm pretty sure you would have all tried that out. So now there are two faces on the spoon. We're going to talk about the face that's bulging inwards, or in other words, concave mirror. So let's take our mirror. Alright, so this is our concave mirror. Alright, so concave mirror, I'm sure you all know that we can assume that this was a huge sphere and we have taken a small arc out of it, or like since we are doing it in a 2D form, we can assume it to be a huge circle. Now that circle must have had a center. So let's put that center. Of course that center will no longer be, you take that center, you draw that arc here. So this can be denoted by C. Now there is another point called the focus, which is exactly halfway between center of curvature. Have we proved it? No, we have not proved it. You can find it online. So we'll explain this later on. By the end of the video, I'm sure you will be clear on this. So now this is a spherical mirror. Now you obviously know that the laws of reflection are followed here too, which are angle of incidence equal to the angle of reflection. So now where is the normal here, you can ask. That's a very valid question. So let's consider a small circle here. Alright, very good circle, it's not well drawn. So this is the radius. Now let's draw a tangent. You're going to learn this in geometry. Now this is the tangent. Alright, this is the tangent. And you can draw infinite tangents for a circle. Now this is a law in geometry which states that the tangent is perpendicular to the radius at the point of contact, this. So there are infinite tangents like this. And to each one of them, this one is perpendicular, infinite tangents, which promotes us to think that any ray of light or any line passing from C will be perpendicular to this mirror. After the video, you might want to open your book and check out this. Alright, so right now we have a spherical mirror. This is called the pole. The pole is basically the center of the spherical mirror. Alright, so now we have our pole. Let's send out a few rays of light. Let's play with them, let's try to see. Alright, now we've taken a very special case. Now this ray of light is parallel to the principal axis. What does that mean? Where will it go up? Alright, now let's draw this. Now this is the angle of incidence. Now this is the angle of reflection, and this ray you find out that will pass through focus. You set out as many parallel rays as you can. They'll all pass through focus. So this was the case 1. Now you can take any ray, you can take the line, you can find out the angle of incidence, you can do this. But if you're lazy, if you're all smart, so you're gonna take these. It's just a very simple case study. Any ray of light parallel to the principal axis will pass through the focus. Now this is also vice versa, which is any ray of light passing from the focus. After it touches the mirror, it goes parallel to the principal axis. So we have 2 rays here. A third ray can be, now any ray of light passing through the center of curvature is normal. At the normal below it retraces its path, thus it will go back. So we have our three rays of light. 1, 2 and 3. So this is all for now. So you stay home, stay safe and keep learning, and I'll get back to you in some time. Thank you.